Let's talk our way through one more example of graphing, and then we're also going to talk about what to do when it comes to rearranging these equations and inequalities. We got to be very careful when it comes to isolating y. So we're going to go over a note about that. But before we get to that special note, let's talk about problem number 4. So we want to identify what is our a value, in this case, positive 5/2. What is our h value, which is coming from inside the absolute value. I see x plus 3, so that means h is -3, always the opposite sign. And now k, well, what on earth is k? There's nothing there. Well, if there's nothing there, that means it must be 0, okay? Describing our transformation, since a is positive, it's going to open up. Since a is bigger than 1, okay, the absolute value of a is bigger than 1, that means it's going to be a narrower or a steeper graph than the parent function. All these transformations are in reference to the parent function that we did at the very beginning of the lesson, by the way. H is -3 means we're going left 3. There's no vertical shift. Okay, there's no vertical shift here. So that means our vertex is at the point left 3 is -3 and 0. Okay, so -3, 0 is our vertex. All right, a is positive 5/2, so that means I need to go up 5/2 in both directions. So I need to go up 5/2. That's this point right here. And then I can use symmetry to plot the other point, or I could count up 5/2. I can't quite fit a second set of reflection points on here. I would have changed the scale to accommodate that if I was doing this on homework or a test. But I'm just going to stick with counting by ones. Draw my 2 lines coming out. There's 1. There's 2. All right, so there's my absolute value function. And one last time, let's go over how do we change it to make an inequality. Let's duplicate that and put it right here. Okay. So our inequality in this case, it says y is greater than or equal to. Greater than or equal to means shade above. And the equal to means I'm going to keep a solid line. All right, so now I just need to get my shading going. I'm going to start my vertex, go straight up for my vertex, which is going to be inside again. Okay, so I'm going to shade everything inside. All right. Okay, now let's get to that special note that we were talking about. A special note, an important note about isolating the y. All right, we saw a problem where we had to move something from one side to the other by addition or subtraction, so we just put it at the end. It ended up being our k value. But we need to be very careful when there's a number being multiplied by the y. Okay, so if we are going to divide out a constant, like right here, I need to divide out the 4, and I need to divide out the 4. But only the values outside the absolute value are going to change. The inside is always going to stay the same. So that x minus 3 is going to consistently stay in x minus 3. So this is going to be y is greater than or equal to 2/4 is 1/2. The absolute value of x minus 3 should stay unchanged. And then the 20 divided by 4 is going to give me a 5, okay? So when you're dividing something, only numbers outside of the absolute value change. Nothing gets modified inside the absolute value bars, okay? It's a little bit tricky to explain why that is, but this is something that we need to be able to do, all right? Another important note that's not written here, if this had been -4, what would we also have to change? This would have had to flip around if there were a negative being divided out, okay? Remember, anytime you have an inequality and you multiply or divide both sides by a negative number, that's when you got to flip the symbol around, okay? But I'm going to get rid of all that writing because that's not what this problem actually was, all right? And then we could go through, we could identify a, h, and k, describe our transformations, make our graph, and shade, okay? All right, that's it for our absolute value functions and inequalities. If you have any questions, let me know. Good luck with your homework.